Okay, here's a few integrals. Let's see if we can do them. They say here's a function, 1 over x squared, and they say find big F of x, which would be its antiderivative. So this function is in kind of a lousy form the way it is now. I'm going to reinterpret that as x to the minus 2. Because if I do, then I can use the power rule. And the power rule says the antiderivative of this would be, power goes up by 1, so we get x to the negative 1. And then we divide this by negative 1, so our antiderivative is negative x minus 1. And because this isn't a definite integral, I have no excuse for leaving off the c. That should be there. Next one here, integral of sine x. Well, the derivative of cosine x is negative sine x. So if we throw in a negative here, if we have minus cosine x, then that should give us positive sine as the derivative. So the antiderivative of this would be negative cosine x, and again, don't forget your c. Now they ask the same thing again, only this time it's a definite integral. So, hey, we already got this antiderivative, we might as well use it again. We're evaluating negative cosine x plus c. I'll leave the c in just for fun. And we're evaluating that at pi and at 0. So we get negative cosine pi plus c minus negative cosine 0 plus c. Cosine pi is negative 1. Throw this in, it becomes positive 1. So we get 1 plus c minus cosine 0 is 1. Throw that in, it becomes negative 1. And then plus c again. And that'll clean up to 1 plus c plus 1 minus c, total of 2. And as we kind of knew would happen, the c's canceled out and ended up not mattering. And now, the integral of 4. This is this is almost a math joke here because I'll show you what this means in a second, but first let's get it done. Our integrand is 4, which means its antiderivative is 4x, and we're evaluating that at 3, and we're also evaluating it at 2. I'm not bothering with the c this time because definite integral. Even up here it was a waste of time. I just thought I'd throw one in to remind you that the c's don't have to hurt anything if you do leave them in. So from this we get 4 times 3 minus 4 times 2 comes out to 4. So if you think for a minute about what this integral means, here are some axes. We have a function that is just 4 units. It's 4, 4, 4, 4, 4. And then they have us start at x equals 2 and go over to x equals 3. And we're supposed to find all the area in here. Well, this is a rectangle. It's a rectangle with a base of 1 and a height of 4, so of course its area is going to come out to 4. But doing an integral of 2 to 3 of this constant 4, because this is the height, is just about the most complicated way that you could possibly find the area of a rectangle. You integrate its height over its width, and that gives you the same thing that area equals base times height would have. So if you want to overcomplicate a rectangle ever, this is how you would do it.